Let us learn about the principle explaining flotation. The boy seems interested. Let us follow him into the museum. The boy notices a portrait placed at the center of the museum. The portrait is of Archimedes. Archimedes noticed that when an object is placed in a liquid, the object displaces some liquid. This understanding formed the basis of his further work in this field. Flotation can be understood from Archimedes' principle. It states that when a body is partially or fully immersed in a liquid, it experiences an upward thrust, which is equal to the weight of the liquid it has displaced. Simply put, when you add an object to a liquid, it has to make room for it. So an amount of liquid equivalent to the weight of the object is moved out. The object, in turn, experiences an upward force equivalent to the weight of this displaced liquid. Can you think of any examples where you have noticed a change in the level of liquid after adding a solid to it? The boy moves on to see the next exhibit. It is an experimental setup for verifying Archimedes' principle. Let us try to verify Archimedes' principle ourselves. First, weigh the object to be immersed in the water. The weight of the object is 60 Newton. Now immerse the cube in water. Notice how the upthrust from the water is causing a change in the cube's weight. As the cube is immersed, it displaces the water. The water rises and flows out. The water is collected in a beaker. This beaker is placed on a different weighing scale to measure the weight of the water. Notice that the weight of the water displaced by the cube is 20 Newton. Now recall Archimedes' principle. The cube weighs 60 Newton. When it is immersed in the liquid, its weight changes to 40 Newton. This is because it experiences an upthrust of 20 Newton. According to the principle, this upthrust should be equal to the weight of the water the cube displaces. As expected, the weight of the water displaced by the cube is 20 Newton. So, we have successfully verified Archimedes' principle. Recall the part where the cube was immersed in the water. It is pushed in further, but there is no change in the water level. What could be the reason for this? Submarines use Archimedes' principle. Here is a model of a submarine. The hollow borders shown here are known as ballast tanks. The submarine regulates the ballast tanks to descend to the seabed or rise to the surface of the ocean. To come to the surface, the submarine releases compressed air into the ballast tanks. This pushes the water out, and the submarine becomes lighter. The upthrust on the submarine becomes more than its weight. This pushes the vessel upward to the surface. In order to dive below the surface, the submarine takes water into its ballast tanks. This increases the weight of the submarine. The upthrust acting on the vessel is not enough to keep it afloat. The submarine sinks into the water. Ships, submarines, hydrometers utilize Archimedes' principle. The principle says that the upthrust exerted on a body in a liquid is equal to the weight of the liquid it displaces. Archimedes was a great Greek inventor and scientist. He was the first one to understand the working of flotation. He explained this in his principle.